Hey y'all, forgive the state of the office. It's under construction right now. So today I'm going to jump into Scenario Processor and just explain very high level how it works, a little bit of the coding behind how you can configure your own Scenario Processor if you were to get a license for it. So I won't dive too deep into any of the other products, as I've done another video where I talked at length about each of these. In short, you use Studio to hone in on what your recipe for a CAD asset will be to come all the way through into polygons. So you optimize, tessellate, decimate, all that stuff. And at the end of it, you have this really nice optimized piece of polygonal mesh. Scenario Processor is essentially the headless version of that. So once you have everything dialed in Studio, you have your recipe, you push that to Scenario Processor, and then it can iterate on that in a headless fashion over and over again to automate your pipeline. So one of the ways that I found most beneficial to talk with customers about Scenario Processor and really show the value is to use one of the sample scripts that have been released online. So we'll dive into that script as well, or that project rather, today in this video. So let's go ahead and poke around a bit. First thing is some documentation. I'll include links to the previous video that I did on the Pixyz Studio pipeline, which is going to lean into how you would leverage that recipe into this video. I'll include this link here for documentation, as well as a couple others that we'll look at in just a second here. So just to look at about Scenario Processor. So in a nutshell, this is a great doc that I'll post a link for that explains how you use Scenario Processor and what the value proposition is of the platform or of the product. So here's some about here that you can dive into. I'm only going to cover floating licenses today, and I'm going to cover it very quickly because I don't want to make this a deep dive into license setup or FlexLM. So if you click on floating license over here, and then you hit on the link right down here. So you have to use floating licenses in Pixyz Studio. A FlexLM license server is required. I tend to always use floating licenses when I'm working with or at larger kind of Fortune 500 companies. It's just a more efficient way of working, I've found. So I'm going to click on read more, or in this case, I already have the instructions here. This is another link that I'll include, even though you can get to it from the previous. And this basically walks you through all of the install settings and parameters. If you're at a large company, you're likely going to want to work with your IT team that's going to need to go into one of the systems that they have. If you already have FlexLM running, it simplifies this process even further. If you don't, you do need to spin up FlexLM. So here it talks you through obtaining a license from Pixyz for your FlexNet server. So the idea is that essentially you're going to get the host name and information from your computer that you're running FlexLM on. Then you're going to go back into your Pixyz dashboard, which for those of you that have not been there, the URL is not the same URL as the Unity login. So you have your Unity organization ID, then you have your Pixyz login. As of today, and I've heard many requests to consolidate these, which I completely understand. You need to go to this separate website to log in. So I have my login here. I'm going to log in, and then I can get into my license management, my admin portal. So if I go to license management, I can see what I have down here. I won't risk going into any of that too deep, but that's the idea of where it's at on this next step. So if you're setting up a floating license server, you can then go in here, activate your server with the information that it's prompted you to get earlier here in the process. Type that stuff in, and then it talks you through how to set up and start FlexNet server and service. So I'm not going to go into that deep at all. Once you have it all set up, then it's just a matter of typing in the correct information so that your software can then see the floating license server running on the FlexLM. So this is what we're going to be doing today. The idea is that this is really all that you need. It's just this line of code that is populated by the address, in quotes, comma, port number, comma, true, is what you'll want to have checked there. So the easiest way to do that is going to be to come down to your search, type in scenario processor, and you can run the app here. You can also, and this is all assuming that you've installed the scenario processor from the web. So you have this, I've pointed you to the URL below. You go to scenario processor, download that executable, and then you launch scenario processor from wherever you've installed it. So like mine, if I open file location, is here programs scenario processor, but that's a shortcut. So let me see where that file location is. And now here is the app. So this is the app that I needed to run. Once the app is running, it is as simple as pasting that line with the specifics that you have from your FlexLM server. So when I hit enter, it's going to execute, set it all up. We're good to go. So that's the entire setup. If you ever do need help, feel free to reach out and I will point you in the right direction. The place that I want everybody to start, though, or at least this is where I would recommend to start, is if you just Google Pixyz Scenario Processor Folder Watcher Demo. Alternatively, I will have the link in the description for this video. It's going to take you to this URL here, which is all public information. But inside of here, you have a samples and ready to use scenario. So I'm going to open that in another tab. And then we have this sample that is going to run on Python. And then we have another sample that's packaged as a plugin. So I want the Python-based one. I'm going to click on this sample here. And now I can look at this. We have a scenario processor samples project. So from here, I would just download the zip, get it local, and then this is what it's going to look like right over here. So you're going to have scenario processor sample main with each of these main folders here. And the one that I tend to work within is folder watcher, the 1_. So once I have clicked on that, actually one thing before I dive any deeper is that you're going to want to, and it may say this in the setup README. Let me see if it does. If not, then I'll just say it out loud here once so that you're aware. Okay, so this does have some good information. The thing that I don't know if it says in here anywhere, but that you will find out quickly, is that you must have Python installed for this to run. I know that seems silly for me to say, but it has certainly caused much confusion previously. The way that it's recommended to get Python through the scenario processor documentation is through the Windows Store. So I won't take us all the way through there, but you go into the Microsoft Store, you search Python, you download the most recent version. I forget if it requires a system restart or not, but that's basically all of it. And if you run scenario processor without Python installed, it will essentially flag an error within the command line window and say something about Python missing. And that's what that error means, is that you need to go in and download Python. So to dive back into 1_ folder watcher, the way that it works is very simple and extremely powerful. So you have input, output, scripts, and then I think I just have a test folder in here for some other stuff for old configuration files. So this is a service, or rather a product that will run as this Windows batch file down here. And as it's running, when I double click on it, assuming that it has verified that you have an active license and you have Python, it's just going to say here, waiting for files to process. And what that means is while this is running, it's looking at your input folder. And if it finds anything in there, it's going to spit out the processes that are defined within another script that I'll point you at in just a second. So the input folder is empty, so it's just sitting here waiting. We have an output folder that I need to go in and scrape out some internal files before I dive into too far. And then we have scripts. So config.json, and then your sample script and your watcher script are the three core elements of this folder watcher demo. Let's open up the config.json first. So I'm just going to open that with Notepad. And here we have input folder is underscore input slash. So that's essentially indicating that this is the folder that is designated as the input. This is the folder designated as the output. And we're going to say true, which if you have true turned on here, it's then going to go through all of the optimization within your sample script.py that we'll look at in a second. I have culled down the amount of extensions that I have here. I think the basic file has something that looks a bit more like this. So you have a bunch of these different extensions, meaning when you put one file into the input, let's say it's a cat part file or an IAM, an IPT. Let's say that any of those types of files process through, when it spits out into the output folder, you're going to have one of each of these. So it's extremely efficient in that way. Then these scripts that we have here, sample script, I'll open with Visual Studio. And this is kind of the meat and potatoes of the recipe that you're going to activate. So everything in here, we can dive into all of it. If you're having significant issues with the files that you're importing, there's a potential that you'll need to do as I did in this file, which is this last variable here that's true or false next to the Pxyz process.import options. I've set to true, meaning that it is preferring an alternate importer. You only want that on if your files in bulk are not working with the standard importer, in which case I would set that to false. By default, this is set to false, but I've been running some tests lately for a customer that is specifically looking for help with files that are not the friendliest with the default importer that we have. So that's a setting to know. If you start hanging on certain percentages of completion, or you're seeing some glitches or issues right up front and it really doesn't process your file, that's a great place to start. Just to dive down through here, this is what we care about the most, which are all of the settings that you're going to customize. So this one is customized a bit. I've commented out a couple pieces, which is just the hash symbol, which is a report out on the initial triangles, verts, and parts, and then a report out on the optimized triangles, verts, and parts. I think that's great to have in. I wouldn't recommend commenting it out, but for speed of iteration, I just commented anything that I didn't feel like I wanted to be looking at every single time that I ran the process. So in here we have repair CAD, tessellate, select by maximum size, and then delete that selection. So if you want to select everything that's smaller than 15 millimeters, let's say, and then delete it, that's what's happening here. Then you have remove holes, a decimate, delete lines, delete patches, hidden removal, merge parts. So you can see as we're going through here, these are all processes that run within Pixyz. Some of these you can see I've doubled up on, which is not an efficient way of working, but for the sake of this video is kind of irrelevant. So I've added in a few extra lines, and it's gotten me to a good spot with the types of files that I'm working with for right now. You can effectively leave everything else in here where it is. This is the main bulk that you're going to want to be changing. So let me minimize that, and then I'll open up the watcher. And the watcher is basically the script that is running and watching, right? Kind of indicated by the name there. But the idea is that this is what is running and looking at that input folder to see if something needs to be processed. This is also the script that will check and see, I believe this one checks and sees if optimization has been set to true, then it will start the other sample scripts file to start optimizing, I believe. But essentially these three files work in concert. So sample script, watcher, backups is just an old file that I have in here. It could be deleted out. But these two and your config.json. So right out of the box, that's what I would be working with and kind of customizing. You really don't want to customize your watcher script just worry about customizing that one block within your sample script.py. To show you a quick explanation of where these scripts are coming from in that block that I'm telling you that you should be able to customize and kind of iterate on, let me open up Studio very quickly. We'll take a look together and I'll point out where you can start to look at where these scripts are coming from, and we will be good to go. So Studio is going to open up. I'm going to close out of this window. There are a couple places to go. One of them is sample scripts here in the bottom. And you have a ton of really good sample scripts. One of the ones that you can see here I already have up is 101 generic process. So I'm just going to pull generic process 2 down. And all of these are scripts that you could effectively copy and paste. So if I wanted to say, let's say delete patches, I'm going to copy that, come over to sample script. And now theoretically, I could just create a line and paste that here. You can see it lines up with the algo definition that all the other lines have here as they're needed. The only thing that I would change here is that root is a common thing to call like the root of the scene. So coming back into our scene here, this would be root. It's also, and this is my understanding of it, I'm not a Pixyz engineer, this is just what I've come to understand, is that having 1 in the brackets indicates the first line in the hierarchy tree. So it basically goes to 1 in your tree, which is usually the highest level part that you have in the scene. So I'm, instead of using root, likely going to change this to brackets 1, and that lines up with everything else that I have in here. I think that's just the nomenclature that I want to be using. Instead of having root there, I don't think it's scene breaking, but that's why. If you're looking at this and you're wondering why I have 1s here, that's what I've done. You can also go into anything that you're going to do, like a decimate to quality, and you can say copy Python code to clipboard, and then you can go into any script. I'm just going to do this at the top of this script, so I'm not making a whole new window, and I can paste. So that's copied the script to the clipboard that I want to be using. So now that I see what this is, I can go back up here to optimize mesh, decimate to target, and see very clearly what these numbers mean. So in parentheses 1 means, again, that part of the hierarchy tree. Then I have 0.5 listed out, which is my surfacic tolerance, 0.1, my linaic tolerance, 1 for my degree of normal tolerance, texture coordinate tolerance, it has a -1, and then false is this Boolean here for release constraint on small area. So that's how these work. Everything that you have in your UI, for the most part, has a script that's being ran when you're executing that part of the UI. So that's how you would get your different pieces of code. And basically you would come back into your sample script.py and just start putting in, let's go to the correct script, start putting those in as you so choose and see where it breaks, see what happens, dial parameters up and down. Ideally, what you've done is you've already honed in all of your parameters on the correct numbers inside of Studio, because it's a lot faster to iterate and you can visually see the changes that you're making instead of running it in Scenario Processor, seeing the vert count, and then thinking that that's the way to kind of iterate. I think you'd be working a bit backwards. You really want to go inside of Studio, fine-tune your recipe, and then bring the recipe over here. So with all of that, I have waiting for files to process. I'm going to go into my test generic data and my input folder that I have here. And let me just delete all of these out. And I'm going to pull over, let's do the radial engine step file. So I'm copying that. One thing to know, I believe it's in the watcher script that there is a line that deletes the old file. That's so that the watcher can just delete that file and move on to the next one. So if you put 5 in, it will execute all 5 back to back because it continues to delete the highest level that it's just executed. So you can take that line out, but just know if you drag a file over into your input folder here, it is going to delete that file. And oftentimes it doesn't leave the former file in the original folder. So you can get yourself in a bit of a bind quickly if you don't have backups of this file. All right, so what I'm going to do now is just set things back up how they were when I originally had this project. Go back up into scripts. And I believe backup, let me do sample script.2. And I believe this was sample script. Let me open that with Visual Studio and double check that that is accurate. Yes, so this is as it comes. So it's going to run the sample script. I'm going to close this out, rerun it, open my input, take Radial Engine step, copy, paste it over here in the input. And now it's going to execute here in the main window. And while it's executing, there was one other script that I wanted to show, or rather one other resource that I wanted to show, and that is the Pixyz documentation for different scripts. So if you just Google Pixyz API reference, and again, I'll put this link in the video. When you click on it, you can get into any of these scripts that generally will help you, let me not zoom way out as I'm talking through it, that will help you do any of the processes that you need to. So if I want to search, decimate was the last one I was looking at. I can then see that I have decimate, so that's animation by channel segment. Here's just the regular algo decimate. And then it's going to explain what each of these things are. So it tells me what each of the numbers mean, what each of the Boolean true or false means, all that good stuff. So we can now see over here, because I reverted back to the files that came with the original demo, we have the triangles, verts, and parts all back up here. So it's showing you the original and the eventual after optimization. And let me come over here to input, folder watcher, output. And here's our radial engine. We have a 3D XML, an FBX, a GLB, an OBJ, whatever this one is, a PXZ, and a USDZ file. Just because I'm interested to know. This is a PDF, so it exported as a PDF as well. So that's all we have today. I wanted to walk through that with you very briefly, show you what Scenario Processor is, how it runs, point you at the demo project that you can pull down locally. Give this a try, start to hone in what variables you want to really get honed into the right numbers for your different types of assets inside of Pixyz Studio. Get those recipes, send them over to Scenario Processor, and run them headless in an automated fashion. So ideally, you can go home for the weekend after dropping 100 files into your input folder, come back on Monday and see all 100 processed into all of the type of exported files that you needed. I hope that helps. Have a great day. Like, comment, and subscribe, and thank you for watching.